Assalamualaikum and hi, this is chapter 3, System of Linear Equations for AM0043. Okay, let's see the outline of this chapter. First, we will learn about linear system of matrix equations. Second one is about using inverse matrix in solving AX equal to B. Third one, Gauss-Jordan elimination method, and the last one will be Cramer's rule. So basically for this chapter you have to have previous knowledge on matrix. This is what you have learned in previous semester, so we're going to use matrix a lot in this chapter. Okay, so first of all, let's see the linear system of matrix equations. What is linear system of matrix equation is that you're going to consider the system of linear equations with three unknown x1, x2 and x3. So these are the three unknowns. Okay, x1, x2 and x3 with the three different type of different equations. So from these linear equations, are we going to write it down into a single matrix equation as below. So we're going to transform from this equation into this matrix form. So how you're going to write it down is that all the A over here, A11, A12, A13, so on and so forth, this A we call as coefficient. So all the coefficient we compile it into one matrix over here, 3 by 3 matrix. And then all the x1, x2 and x3, okay, we compile it into a single matrix over here. Okay, and the other one over here is the answer on the right hand side, so we put it in as one matrix on the right hand side. So you have 1, 2 and 3 matrix. So this kind of matrix we actually call it, this one is A, this one is X and this one is B. Just like this. This is A, the coefficient matrix will be matrix A, and then this one will be matrix B, and the one that consists of X will become our matrix X. Therefore, the system of linear equation can be written as AX equal to B. Okay. So, yang tadi ni kita boleh tulis semula sebagai AX equal to B dalam bentuk macam ni. Okay, let's see example. Lily wants to buy 3 different flavors of ice cream for her children. So Lily hendak beli 3 flavor yang berlainan untuk anak-anak dia. For the first child, she buys ice cream with cost RM2 for a scoop of strawberry, and then RM3 for a scoop of vanilla, and RM4 for a scoop of chocolate. Okay, so you have vanilla, strawberry, vanilla, and chocolate, 3 flavors. Okay, for the second child, that one is for the first child. For the second child, she buys ice cream with cost RM4, RM3, and RM1 for a scoop of strawberry, vanilla, and chocolate respectively. Masing-masing RM4, RM3, and RM1 untuk strawberry, vanilla, and chocolate. Okay, meanwhile, for the third children, untuk anak ketiga pula, the cost is RM1, RM2, and RM4 for a scoop of strawberry, vanilla, and chocolate respectively. So, masing-masing RM1 ni untuk strawberry, RM2 untuk vanilla, and the other RM4 is for chocolate. So, she buys X scoop of strawberry ice cream, Y scoops of vanilla ice cream, and Z scoops of chocolate ice cream for each child. So we don't know how many scoop. Okay, so we just let as X, Y, and Z. So write down system of equations. If he spent RM34 on the first child, RM28 on the second child, and RM27 on the third child. So dia dah bagi tahu. Keseluruhan dia spend RM34 untuk anak pertama, RM28 untuk anak kedua, dan RM27 untuk anak ketiga. So your task is to write down a system of equation. System of equation tu macam ni lah yang tadi. Either you can write it down in this one, in this form, or you want to write it down using the matrix form like this. Okay, using all the information given to you. So in our case, this is all the information given to us. So we need to extract the information and write it down in as a system of equations. So now we let X as a scoop of strawberry ice cream, Y as scoop of vanilla ice cream, Z as scoop of chocolate ice cream, because it's given all here. It's already given here. X scoop of strawberry, Y as vanilla, Z for chocolate. So from the first over here, for the first child, dia kata she buy ice cream which cost 2 ringgit for a scoop of strawberry. So strawberry represent X. So dia kata 2 ringgit untuk X. So we have 2X and then plus 3 ringgit for a scoop of vanilla. So vanilla represent Y. Y represent vanilla. So we have plus 3Y plus 4Z. 4Z. Z is for chocolate ice cream because 4 ringgit for chocolate. So that's why we have 4Z equal to 34. Where did I get this 34? Is because dia kata dia spend total 34 ringgit for the first child. So untuk belanja keseluruhan ice cream tiga-tiga flavor ni campur ke semuanya, you will have 34 ringgit for anak pertama. And so goes for the same goes for the second child. So what did this the second child have? Okay, dia ada 4 ringgit for strawberry. So you have 4x plus 3y because of 3 vanilla and 1 ringgit for chocolate. Okay, so 4 strawberry, 3 vanilla and a scoop of and 1 ringgit for chocolate, which costs Lily 28 ringgit, 28 ringgit. And the third child, 1 ringgit for strawberry, 2y is for vanilla, and 4 for chocolate, 4z for chocolate. Okay, so all these X, Y, and Z represent something from this problem. So in our case, it represents the flavor. X for strawberry, Y for vanilla, and Z for chocolate. And the thing over here on the right hand side is actually the total given to you. At the total Lily's spend for her children respectively lah, for the first, second and the third children. 34 ringgit untuk anak pertama, 28 ringgit untuk anak kedua, and 27 ringgit for the third child. Sorry. So that is how you obtain your system of linear equation. This is how you extract the information. Okay, so read your problem carefully and then let the unknown, let the flavor, or in our case over here is the flavor, become the unknown, X, Y, and Z. Okay, and then the total here, the usually written down as the last paragraph or the last sentence. That one will be you will have to put it on the right hand side over here. Okay, so this is our system of linear equations. Okay, that one is about what is system of linear equation and how you going to write your system of linear equation. Now we move on to the second part, which is how to use inverse matrix in solving AX equal to B. So I believe that you have learned what is inverse matrix songsang before, but now we're going to use this inverse matrix to solve AX equal to B. So what is AX equal to B? So AX equal to B is actually our system of linear equation just now. So apa tu A? A represent all the coefficient over here. B represent the answer yang sebelah kanan, and X represent all our unknown. Okay. So macam yang ni, in our case, our A will be 2, 3, 4, 4, 3, 1, 1, 2, and 4. That will become our matrix A. Okay? Okay, let me jot down a bit. So from here, you will have matrix A, which is you have 2, 3, 4 for the first row, and then you have 4, 3, and 1. And then the last row, you will have 1, 2, and 4. 4. Okay? So that is your matrix A. And if we refer back to this one, you will have matrix X in between. So matrix X is actually your unknown. What is your unknown here? So your unknown is X, Y, and Z. Ikut urutan. Write it down in sequence. X, Y, and Z. X, Y, and Z. Okay. Equal to our matrix B. So what is our matrix B? This is our matrix B. Okay. So our matrix B will be 34, and then we have 28 and 27. Okay. So this is your this one in written down as system of linear equation. This one is in the matrix form. Okay. Okay, so we're going to use inverse matrix to solve this AX equal to B. Usually AX equal to B ni written down in this form, matrix form ni lah. So using the inverse matrix method in solving system of linear equation. Okay, if the number of equation in the system equal to the number of variables and the coefficient matrix has an inverse, then the system will have a unique solution that can be found by using the inverse of the coefficient matrix. So unique solution mean nombor yang berbeza. Okay. Okay, AX equal to B. This is our system of linear equation. Originally, we have this form. But we want to solve for X. Kita hendak cari nilai untuk X, Y, and Z tadi. Matrix X, Y, and Z yang ni. So, we're going to change or we're going to transform it into this form. Maksudnya kita deduce dia, turunkan dia menjadi yang ini. Asalnya dia dalam bentuk AX equal to B. We want to transform it into this type of equation. X equal to A inverse B. Kenapa jadi macam tu? Because this A, bila you bring it to the other side, it become A, dia jadi bahagi kan. Kalau A ni, we bring it to this side, it become B over A. Ataupun dalam erti kata yang lain, dia adalah 1 over A ataupun A to the power of 1. Ataupun senang cerita, this is what we call as A inverse. This is A inverse. Inverse. This one. Okay. Inverse matrix. Okay, let's see the example. Solve the following equation by using the inverse matrix method. So, kalau dia kata using inverse matrix method, meaning you kena deduce daripada AX equal to B kepada this form, into this form. So, we will need to convert this to a matrix equation of the form AX equal to B. Of course, daripada sini, you kena tukar dia dalam bentuk yang tadi I ajar, this one. Okay, so you have like 3, 1, 2. So that's why you have 3, 1, and 2. And then you have 3, 2, 2 okay, for the second row. So you have 3, 2, 2. And the third row you have 1, and over here 0. Untuk x square, x2 dia 0. That's why you have 0. And x3 equal to 1. And for this is A, this is X, matrix X, and this is matrix B. So, for matrix X, you have X1, X2, and X3. Susun ikut susunan, ikut turutan X1, X2, and X3. And for matrix B, you have this one. Ini yang mat B. This one become your B. 11, 10, and 5. So we already have this matrix AX equal to B. We're going to change it into this form. Okay. So how are you going to change it into this form? Of course, you need to find the A inverse dahulu. Sebelum you cari X tu, you kena cari dulu apa tu A inverse. A inverse tu matrix A yang sonsang kepada matrix A sonsang. So this is what you have learned before in the previous semester, if I'm not mistaken. So the formula will be 1 over, you have to find this is the determinant. This is actually determinant for A. I know most of you already forgot about what is determinant, so please check back your matrices, chapter matrices. This is determinant, and this is all the cofactors. This is all the cofactors that has been transposed. So apa tu determinant? What is the cofactor? And then what apa tu transpose matrix. So nanti you refer balik. That is how we obtain this A inverse over here. Okay. Okay. Then, okay, let me write down a bit. Cofactor. Later on, you have to check back your matrices punya chapter. Cofactor yang sudah kita transpose. Okay. Then we have, okay, since we already have our A inverse, in this case, we already obtained A inverse, which is this one. So we rearrange again X equal to A inverse B. So X tadi adalah X1, X2, and X3. A inverse adalah given this one. A inverse. Okay. This is our A inverse. And our B. B is just now we have our B, this one, 11, 10, and 5. So what happened is that you need to solve for this one. Yang 2, -1, -2, you have to multiply with this. So you have like this. -2 times 11, you get 22. -2 times 10, you get lah something kan. So this one darab dengan ni, and then this one darab dengan ni, and then this one darab dengan ni. So this is a multiplication of matrix, hasil darab matrix. So you will get this form. Okay, since you already have this form yang tadi ni, you selesaikanlah dia. 22 minus 10 minus 10, so you get 2. 11 plus 10, -11 plus 10 plus 0, so you get this one and this one. Therefore, we can say that our x1, the unknown tadi, yang tidak tahu tu, x1 equal to 2, x2 equal to -1, and x3 equal to 3. Okay? So that is how you find, or that is how you obtain your unknown using inverse matrix. So first, of course, you need to change from this form into this form by using inverse matrix. Okay, that is second subtopic. Now we move on to the third subtopic, or the third part, which is using Gauss-Jordan elimination method. We're going to solve that system of linear equation, but this time not using the inverse matrix, but using Gauss-Jordan elimination method. So, apa tu Gauss-Jordan elimination method? Okay, see over here. Gauss-Jordan elimination method. So, the procedure, number one, you have to write the equation AX equal to B yang tadi itu in the form of the augmented matrix. So kali ni dia tukar pula daripada bentuk macam ni, kita tulis dalam bentuk A and B. And then second one, use elementary row operation to reduce the augmented matrix to form a reduced augmented matrix RAM. So maksudnya dekat sini, tak payah pening-pening. Maksudnya dekat sini you have to use elementary row operation. Elementary row operation tu maksudnya nanti ada hasil tambah, or tolak, or darab. Okay, untuk setiap row matrix tu. Okay, kita akan tengok. So this is what we call as augmented matrix and reduced augmented matrix. So this one, A, originally we have A and B. This is augmented matrix. A ni lah yang kita panggil tadi coefficient matrix. Yang perkali untuk setiap unknown tu. Itu kita panggil coefficient matrix. And B is the column matrix. Column matrix yang this one. Ini kita panggil coefficient matrix. This one kita panggil sebagai apa tadi? Ni coefficient and B is the column. Kenapa dipanggil column matrix? Sebab dia ada satu column saja, satu lajur, column matrix. Okay. So we have A as coefficient matrix, B is column matrix. We want to reduce it into this form. Asalnya kita tulis dalam bentuk macam ni, nanti dia akan bertukar. Setelah kita perform elementary row operation tadi, tambah tolak darab tu, dia akan bertukar jadi bentuk ni. IX. I is identity matrix. If you recall, identity matrix mean yang ada 1, 0, 0, 0, 1, 0, 0, 0, 1. That one is identity matrix. Okay, and X. X is the solution matrix yang kita kehendak cari. Okay, let's see the first example for the Gauss-Jordan elimination method. Solve the following system of linear equations. This is our system of linear equation using Gauss-Jordan elimination method. So, first of all, you need to write it down into this form. A given B. A given B. So A, matrix A, apa tu matrix A? Matrix A is the coefficient matrix. Coefficient matrix maksudnya matrix yang mengandungi perkali-perkali dia. So coefficient adalah this one, ada 1, we have 1, 1, this is 1, 3 and 1. Kan? So you have 1, 3 and 1. That's why you have 1, this one is negative. Kan ada negative 1, negative 3 and 1. And then the second one you have 1, 1 and 1. All 3, 1. Then the third row you have 2, negative 1 and 1. Ikut saja. Kita just ambil dia punya perkali dekat depan. Okay, how about B? Matrix B. So, matrix B adalah yang, ingat kalau matrix B dia mesti yang sebelah kanan on your right hand side. So it's you have to write down negative 12, 0 and negative 8. So this is augmented matrix dalam bentuk macam ni. Now we want to change it from this one into this one. Kita mau tukar yang sebelah kanan ni, yang sebelah kiri ni sekarang dia dalam A kan? Dia A. Kita mau tukar dia supaya yang ni nanti akan jadi 1, 0, 0, 0, 1, 0, 0, 0, 1. That one. We want to change it into I matrix. And dekat sebelah sini nanti, bila sini dah bertukar, sini juga akan bertukar. So, inilah dia kita punya solution matrix. Jawapan yang kita hendak cari untuk X. But, how are we going to change this A into I tadi adalah dengan menggunakan elementary row operation. So, apa tu elementary row operation? Dia adalah whether you want to use tambah, tolak, or darab. Okay. tengok dekat sini. Bahagi also can. Okay. Okay, so you have 1, -3, and 1. So dekat sini, kan kalau identity matrix, we have 1, 0, 0. 0, 1, 0. 0, 0, 1. Ni identity matrix. So dekat sini dah 1. So jangan kacau. We start with the first one. This is 1. Sini pun dah 1. So jangan kacau yang row pertama ni. Why don't we change this second row? Sebab dekat sini, this one, kita mau tukar dia kepada 0. You want to change it into 0. Yeah? Kita follow ini. Ikut yang ini. Follow, tukar dia kepada 0. So how we going to change this 1 into 0 is using this one. Row kedua ni, row kedua star, maksud dia row kedua yang kita perform ni, negative row 1 tambah dengan row 2 yang asal. So negative row 1 ataupun kita boleh tulis sebagai row 2 tolak R1. Kan, samalah sebab negatif ni. Kita tulis semula row 2 tolak row 1. So, you have 1 minus 1. You get 0 over here. So, nanti dia akan jadi yang ini, row baru. Row baru ni. Termasuklah juga yang sebelah sini. So, you're going to change all the row. Second row. Semua you kena ubah. Second row ikut operasi yang ini. Dia kata row 2, semua row 2 ni, keseluruhan row 2 ni tolak row 1. So, 1 tolak 1 you get kosong. 1 tolak negatif 3 you get 4. 1 tolak 1 you get again kosong. Okay. Kosong tolak negatif 12 you get 12. So, this is how you change your second row. Okay, so second row kamu dah barulah dapat yang ini. So, kita follow sudah 1, 0. Okay, done. Ini 1, 0. Now, we want to change yang mana pula? We want to change the third row. Yang ni pula lagi kita hendak tukar jadi 0. Okay. So, dia punya step tu senang. Dari atas turun ke bawah. Maksudnya dari atas turun ke bawah. Baru move ke kanan. You tukar dari sini dulu, atas ni. Kalau ini dah 1, you don't have to change. Keep it as 1. You change this second row pula, jadi 0. After you settle, change this one into 0. You change this one pula to 0. Because we want to follow this one, kan? And then baru you go to the right. Tengok apa lagi you boleh change on your right. Negative 1, change to 0 or 1. Di sini dah 1. Okay, so now our next step is we want to change these two into 0. Okay, how are we going to change these two into 0? Okay, so ini dalam erti kata yang lain. Kita tulis sebagai row 3, sorry ya, tolak 2 kali row 1. Samalah macam ni kan. Kalau letak negatif tu dekat depan macam you confuse pula. So why don't you write it like this? Row 3 minus 2 row 1. So row 3 ni, 2 ni tolak 2 kali row 1. So row 1, 2 kali row 1 meaning 2 tolak, meaning like 2 minus 2 times 1. So what did you get? You will get 0, right? Oops, terlebih pula. This one. 2. Kita ikut yang formula ni. Row 3, 2 minus 2 times row 1. Row 1 is this one. So you will have 0. Oops, again lagi dia. Okay, tak apalah. So, you have like, this one become 0. So, sama jugalah. Bukan ini saja you kena tukar. The rest of this whole row. Keseluruhan row ni you kena follow this operation. So, sama juga. Same goes to this negative 1. Negative 1 minus 2 times negative 3. And then 1 minus 2 times 2. And negative 8 minus 2 times negative 12. Semua. Satu row tu sekali tukar. Okay. Then you get this answer. Dapatlah yang ini. Tadi. Kita dah berjaya tukar. Untuk semua tadi tu yang you dah kira-kira. Ni kan. Mengikut kepada formula yang ini. You dapat this new row. 0, 5, negative 1. Okay. So, yang ini dah follow dah. 1, 0, 0 tadi tu kan. Dah follow. 1, 0, 0. Dah settle dah. So, why don't we change yang tengah ni pula. So, we go to yang tengah. Kita mau tukar yang mana? Yang this one pula. We want to change this one to 1. So that we can follow this, fulfill this identity matrix. Kita tukar ni jadi 1 pula. Okay, so how we going to change this into 1? Kita, this second row, this whole, kesemua second row ni, kita multiply dia dengan 1 over 4. Darabkan dia dengan 1/4. So, bila 1/4 darab 1/4, you get 1. Dekat sini. Dapatlah 1. Okay. 1 over 4 times 4 tadi. Allah. One over 4 times 4, so you get 1, yeah? Following this formula. So, sama jugalah. This formula applies for all the row, the second row. Jangan buat untuk satu ni je, buat juga untuk ni. 0 times 1 over 4, still you get 0. Okay? And then 12 times 1 over 4, you get 3 over here. Okay, solve untuk yang ini. Apa lagi yang kita boleh tukar? Kita dah ikut 1, 0, 0 and then we have 1 already. Okay, why don't we change this one pula? I want to change this one into 1. Kan? Kita nak tukar dia jadi 1. Okay? So that dia jadi identity matrix 1, 1 and 1. So how are we going to change this one into 1? Guna formula ni. Ataupun ni samalah juga macam row 3 tolak 5 kali row 2. Row 3, this row 3, negative 1 minus 5 times row 2. Okay. Oh, I'm sorry. We're not supposed to change that one first. We need to change this one first. I'm sorry. Okay, my mistake. Okay, sorry. Again, my mistake. We're not supposed to change this one. We need to change this one first into 0. Okay, let me erase this one first so you won't get confused. Okay, so instead of changing this one, we change this one first. Sebab ni kan 5 besar sangat. We want to change it into 0. So how are we going to change it into 0? We're using this formula, elementary row operation, which is R3 minus 5R2. Okay. R3 minus 5R2. So, this whole row, you're going to follow this formula. So like this, row 3, 0 minus 5 times row 2. So 0 times 5 kali kosong, kosong jugalah, tidak ada kesan. When about this, you change this one, 5 minus 5 times 1. So you will have 5 minus 5 times 1. So of course it's going to reduce into 0, kan? Sama jugalah untuk this one pun, you follow the same formula untuk this one pun. So at the end, you get this new thing, this new row. Hasil daripada you ubah yang ini tadi. So you dapat ni lah. Okay, apa lagi yang kita boleh tukar? So next we going to change this one into positive 1. We want to change it into positive 1. So how we going to change it into positive 1? Kita darabkan dia dengan negative 1. Row 3 multiply with negative 1. Okay, atau sama jugalah dalam arti kata ya, tulisan lain, negative row 3. So you multiply lah. 0 times negative 1, 0. 0 times negative 1, 0. Negative 1 times negative 1, you get 1. 1 times negative 1, it become negative 1. So this is the new one. The new row lah. Bila you dah tukar, dia dah jadi macam ni. Selepas you darab negative 1. Okay, apa lagi yang kita boleh tukar next? We want to change the first row pula. Ini dah settle dah 0, 1, 0, 0, 0, 1. Yang ni lagi kita kena tukar 0 and 0, right? We want to change it into 0 and 0. So, which one you think yang easier? Okay, since we have 1 over here, kan? This is negative 3, this is 1. So, of course, I want to change this one first. Ambil yang kecil. Usually, we pick the one yang smaller ataupun yang lagi kecil. That is easier. Smaller. You pick the one yang smaller ataupun easier to reduce. Okay, so negative 3 and 1. So 1 is easier, kan? Kita settlekan yang 1 dulu. 1 ni kita kena reduce to 0. Okay, so how are we going to reduce it into 0? Kita buatlah using this formula. R1 minus R3. R1 minus R3. Ni R1. R3 adalah yang ini row. RR ni semua maksud dia row. So R1, 1 minus 1, you get 0. Negative 3 minus 0, you still get negative 3. That's why you have this new row. So last, you're going to change this one into 0. So how are we going to change it into 0? Using this formula. Or you can write it down as R1 plus 3 times R2. R1 is 1, negative 3 plus 3 times R2. This is 3 times 1. So, bila you tambah, akhirnya dia akan jadi kosong. So, dia akan jadi kosong. So, now, this one become your identity matrix. And this one become your X matrix. So, this is what we call as reduced augmented matrix. Ataupun tadi kita panggil RAM tu. Dah kita reduce. So, our X, kita tahulah this is X. This column is X. Ni dah jadi identity matrix, kan? Selamat dah kita tukar semua. So, your X equal to negative 2. Sorry, your Y equal to 3. And your Z equal to negative 1. So this is how you solve your x, your unknown xyz using the Gauss-Jordan elimination method. Satu-satu you kena tukar sampailah dia jadi macam ni, identity matrix. So for conclusion, we can say that the procedure originally you have A given B. Apa tu A? A is the coefficient matrix, B is the column matrix yang sebelah kanan. Then kita want to reduce dia into this form. Tukarkan yang daripada A tadi tu, nombor banyak-banyak tu, tukar menjadi I. I tu ada identity matrix yang tadi ni. 1 0 0 0 1 0 0 0 1. And X the solution matrix. Okay.